Hello and welcome back, probably. In the assignment I left you with 2 weeks ago, I promised you I would do a live coding session demonstrating the resolution of the assignment, and I did that because it went live last Sunday. But I also promised that as a bonus, I would explain how, rather than pulling the numbers out of your posterior, we could actually calculate them. Then I found out that this combination would lead to a video of over an hour, so I decided to split them up. So here's the bit where we actually get to do some light mathematics. Don't worry, we won't do any trigonometry. We will just have some fun doing basic multiplication and division using only one magic number. And you can enjoy seeing me screw up a few times. So without further ado, let's get cooking. Good. Let's start with calculating the surface area of a rectangle. That's the easiest one of the bunch. To calculate the surface area of a rectangle, we need to multiply the width, not sure how to pronounce that. I'll pronounce it width from now on. So, we need to we need to multiply the width and the height of the triangle.
No.
So, let's see if we can actually provide some values for that. So let's create a property, which is an integer. That's fine with me. Like so. And let's do the same thing for the height property, like so. Now, just having the properties in itself doesn't help. So let's make sure that we can set them in width and in height, like so. And let's say this dot with this dot with equals width, like so, and this dot height equals height. That should do it. Now, when we actually get these, which we will have to make sure we do that here, so let's give it a width of 5 and a height of 3. That takes care of our call to the constructor. Now here we can, rather than return a random number, we can return width times height, like so. That will give us the surface area. Now let's see if this works. In the call to creating the rectangle, we provide a width of 5, a width of 5 and a height of 3. So we would expect the surface area to be 15 units. Let's run it and see if that works. On the other screen, of course. And here we go. That actually works. So we're good there. Now, the triangle is a little bit different and also a little bit more difficult. So what I would normally do, being the old-fashioned guy that I am, is I would draw in a whiteboard into the room. I would get my, not my permanent markers, but my whiteboard markers, and I would show you on the whiteboard. Now, that's a bit hard in YouTube, but I have found a workaround for that. I'm going to see if, here we go. If I can share the whiteboard that I have on my Surface. So, here you see my Surface. Let's show that it works, like so. And I'm going to draw you a triangle. So this is the base of the triangle. And here we provide the... that's a bit crummy, but just imagine that this is a straight line, okay? And here we have the other side. Now, how do we calculate the surface area of this one? Well, we know the height, which is this one, and we know the base, which is this one. So, if we use this to draw a rectangle around it, like so, that's a bit of a crummy drawing, I admit, but you see that the side of the triangle exactly cuts this rectangle through the middle. So this triangle is just as big as this triangle. And here the same thing happens. The side of this triangle...
What are you talking about?
Yeah, I can point with my pen to my screen of the surface all I want, but that doesn't help. So let's do that again. We see that if we draw a rectangle around it, the rectangle has two rectangles. In fact, this one and the big one over here. And you will see that the side of the triangle exactly cuts this rectangle in two equal bits. So this triangle is just as big as this triangle. And here the same thing happens. The side of the triangle slices the rectangle exactly through the middle, this rectangle. And that means that the triangle is in fact half of the rectangle. The same thing here. We have this rectangle, but the triangle is half of that. This triangle is half of this rectangle. So, if we would calculate the surface area of the rectangle by multiplying this by that, and we would divide that by 2, we would have the surface area of the triangle. Now, if you don't get this, because you hate mathematics anyway, just assume that I'm right here, which I am, and let's go back to our code, which is here, and let's go to the triangle class, where, yeah, I should click here probably, triangle. Let's take the code that we did in rectangle, which is, okay, calculate the surface of this rectangle here, that one. Where's my code? Here's my code. So we copy this, we go to triangle, and we say, like so. And we are going to divide that by 2. Now, of course, we don't have width and height yet. And for a rectangle, it's not called width and height. We will call for the triangle. Where is it again? Here it is. We will call this the base, and we will call this the height. That's the same thing. And that's also easier to pronounce than the width for the rectangle. So we're lucky here. We're done with the word width. Let's create a property int base. And let's create a property for the height as well. And let's provide the values for this in the constructor. So int base, int height. Yeah, can't type today. Like so. Oh, this is a reserved word. Yes, this is true. So we're going to call this the triangle base. I know this is ugly, but using another word than the word base is also ugly because that's how mathematicians say it. So we are going to say this dot base equals base. No, triangle base. And this dot height equals height. Okay, recapping quickly. Base in the constructor would be a reserved word because it's already used here. So if we simply type base here, it thinks, right, we're referring to the base class here. That's not true. So we cannot use the word base and we have to think of something else, which we did here. Good. Let me see. Here we are returning not width, but base. Like so. Times height. And we divide it by 2 again because this is half of that. This is half of that. So the triangle is half of the rectangle. Any questions? No questions? Good. Now this should actually work. Let's give it a shot. No, there are build errors. Why are there build errors? Because we have changed the constructor to also want an integer for triangle base and an integer for height. We have spelled this wrong. That's not the error, but let's correct it anyway. Like so. But when we called the constructor, we didn't provide these values. Now, to keep things easy and easy to compare, we are going to give the triangle a base of 5, and a height of 3. I said 3. I have a bit of trouble with the keyboard today, and the keyboard is winning every now and then. But we've got it sorted now. We should be able to run this. Let's see what that gives. Yeah, there's something wrong here. It says Pythagoras' surface area is 7 units. What we would expect is 7.5. So let's see how we can fix that. I can hear some of you shouting the solution in the background. It's actually quite simple. When we calculated the triangle, which is here, we used a base, which is an integer, and the height, which is also an integer. So the return value is going to be an integer, unless we cast it to a float. So if we do this, and we close this, and we rerun the thing, it should give us back 7.5. See, there we go. Oh, wait. See, there we go. Please note at this point that I'm in the Netherlands. We don't have decimal dots, we have decimal commas. and we have 1,000 separators as dots. So this is, in fact, you should, if you're in the US, you should read this as 7.5 rather than 7,5. But the calculation is correct. We've cracked that now. So let's go on and see if we can figure out how to calculate the surface area of a circle, so that we can fix that one as well. So first of all, we need to figure out how we describe a circle. We can describe a rectangle by defining the width and the height. We can define a triangle by defining the base and the height. How do we define a circle? Well, let me show you. That's here. Or is it here? It's here. Okay. Now, to describe a circle, we need to determine the middle of the circle, which would normally go like so. And the circle is the circumference around that. Now, let's just imagine that this is in the middle, like so. And the radius of the circle is from the middle to the edge. Imagine this like you would imagine a wheel of a bicycle, and the spokes would more or less be the radius. Now, if that's clear to you, you know what the radius is. So let's call that R. If this is all Greek to you, then I would say at this point, let's just wait until we are starting to write code again. Actually, it is Greek because the Greeks were good at mathematics. There is a magic number that we need to calculate the surface area of a circle, and that is the number pi. Pi. And the value of pi, it's a constant, is something like 3.14159, and a lot of digits behind that. I don't think it ever ends, but you're pretty close if you remember it's to 4 digits. I know 5. I don't know what comes after that. I don't care. Because we can, when we go to the circle class, which means I have to get this one out of the way, we can actually use the number like so. Math for mathematics functions, and then pi, which is in capitals because it's a constant. This number we need to calculate the area, the surface area of a circle, and we do that by multiplying pi by radius by radius. We haven't got radius yet, so let's make sure we get that first. Let's click here. So we create a new property, which is an integer for the radius. That's the number r. And we are going to get that property from the constructor. Radius? No. Good try. Radius equals r, radius with a non-capital R, like so. Now we can multiply math pi with radius to the power of 2. So that's, to make it easy, radius times radius. Maybe that. Okay. Now we don't need to put anything in between brackets because this is all multiplication. We don't care in which order that is executed, but we do know that we need to cast this to a float. Good. This is how to calculate the surface area of a circle let's see if that works. We will need to change something in the program because we will need to specify the number for the radius. So let's do that. Let's create a circle with a radius of 6. And let's see if we can actually get a believable number out of that. So we run this, and of course it appears on the other screen. Now, if we create a radius with, if we create a circle with a radius of 6, the surface area is going to be 113.097. This seems about right. So let's just trust me, this calculation is correct. And we have now successfully done everything that I promised you I would do when I gave you the assignment. Now, the next installment I plan to be about um, interfaces. Interfaces was the other part of polymorphism. So if we have interfaces and we have that clear, and we can integrate that with the use of inheritance, we actually have the complete picture of polymorphism. Again, there's more to there can be more to polymorphism. We can play around with generics, but that's a matter for another time altogether. Good. I will post this code into the GitHub repository that is part of this particular series of videos, and I will provide the link down there in the description somewhere. Now, down there in the description, no, down there, you will also find the like button, which I hope you will press for me. And if you haven't done so yet, there's also a subscribe button there. If you subscribe to that, you will be posted once a new video comes online in this series. And that would also help me in getting some YouTube preference, if you know how that works. So if you could hit the subscribe button as well, I would be very pleased. Good. Is there anything else I need to tell? Yes, if you have any questions, you can put them either in the comments or you can send an email to the email address, which I will also put in the description of this video. So that's it for today. You'll be very happy to hear that I'm done talking for now. And I will hopefully see you next week when we are back with the first installment of the series about interfaces. Bye for now. Cheers.